Alright, this would be the explanation part. Motion in one dimension, A1. Compare and contrast distance versus displacement. Distance is just the amount of space between two things, and displacement is just distance with direction. A2, what is the difference between velocity and speed? Velocity is the distance traveled by an object per unit time in a particular direction. Speed is just distance traveled by an object. A3, apply kinematic equations to calculate distance, time, or velocity under conditions of constant acceleration. And for the calculating part, it's important to note that I split up each part as the beginning and the end. So I split up all my parts on different segments. So my velocity final in one section would be the velocity initial in the beginning of the second section, which helped me solve for the velocity. Alrighty, so under constant acceleration, golf ball going down the blue mat, I use my kinematic equation just to solve for the velocity final. The velocity final equals velocity initial plus acceleration change in time. For A4, calculate the displacement, velocity, and the time at various points of motion in a free-falling object. For this, I basically used whenever my golf ball was falling and then landing on the wires, I calculated my velocity final of our launching system that led down to where the ball was going to drop, and I used that as my velocity initial, and then I used my kinematic equation to solve for my velocity final. In B1, distinguish between a scalar and a vector. Scalar are quantities that are fully described by magnitude alone. Vector are quantities that are fully described by both magnitude and direction. B2, describe the path of a projectile as a parabola. Whenever the tennis ball was falling down and landing onto the wires, once it hit the wires and ramped out, I basically used that as my parabola, which just means that on any two given points on the parabola, the ball reached the exact same height twice. B3, resolving vectors into their components and applying the kinematic equations to solve problems involving projectile motion. For this, I calculated my velocity final after coming right out of the parabola because, for an example of this, I was using whenever my tennis ball goes across the table. So I measured the distance of it going across the table, and I used my velocity final of coming out of the parabola, and I used that as my velocity initial going across the table and just solving for my velocity final. C1. Contact forces are forces that act at a point of contact between 2 points. Field forces are just forces in which bodies interact without directly touching each other. C2. Interpret and construct free body diagrams. I used this whenever my tennis ball was falling before it actually landed onto the metal wires that guided it to the table. It would just be the force of gravity that would be pulling it downwards and the force of air resistance going against that or upwards. C3. Explain the relationship between the motion of an object and the net external force acting on it. When the dominoes hit each other, the motion of the object is them falling over, and the net external force acting on it is the other domino hitting it. C4. What does Newton's third law state? Identify action-reaction pairs. Explain why action-reaction forces do not result in equilibrium. For every action, there is an equal and opposite reaction. Again, another action-reaction pair is the dominoes hitting each other. They don't result in equilibrium because the action force and the reaction force don't act on the same object. C5. Describe friction and explain the difference between static and kinetic friction. Friction, the resistance that one surface of an object encounters when moving over another. Static friction is the force that keeps the object at rest, like when the golf ball was sitting on the desk before the dominoes hit it. Kinetic friction is the force that acts between moving surfaces, like the golf ball going down the tube. D1. Identify when work is being performed in a variety of situations. The golf ball was performing work when it was hit by the domino and rolled down the tube. The first domino performed work when it was hit by the tennis ball and it hit the second domino. D2. Distinguish between kinetic energy and potential energy. Potential energy is stored energy in the object due to its position of its configuration. Kinetic energy is energy which a body possesses because of its motion. D3. Classify different types of potential energy. A coiled spring, a stretch rubber band, a raised weight, a bow with its string pulled back are just some of the examples of potential energy. Calculate the potential energy associated with the object's position. So I use potential energy gravity equals mass times gravity times the height. Now I had to transfer my mass of my golf ball from ounces into grams. So I multiplied that by gravity, negative 9.81 meters per second squared, times my height, which again I transferred into meters, which would be 0.4572 meters, which gave me a potential energy of gravity to equal 340 joules. D5. Identify situations in which conservation of mechanical energy is valid and solve problems using conservation of mechanical energy. Conservation of mechanical energy is valid when the tennis ball slows down from hitting the dominoes. For this, I use the equation mechanical energy equals kinetic energy plus potential energy gravity. But for this, I calculated the mechanical energy of the tennis ball going across the desk, which means my height would be 0. So this would get rid of my potential energy gravity. So it would be mechanical energy equals kinetic energy. After doing the equation, I got my mechanical energy equaling 3.61 joules. Extra credit, section A. Construct and interpret graphs of position versus time. Now I use this whenever my golf ball was hit by the dominoes going down my blue tube. So I knew how long it took to go down the tube, and I also knew how long the tube was. So I basically divided by fractions using 1/4 just to one scale to determine halfway, 1/4, and 3/4 of the way by how long it would take and how far that actually was. Section B. Recognize examples of projectile motion. When my tennis ball ramped off my parabola, it was traveling in the x and y directions, making the parabola landing on the table. Section C. Explain how force affects the motion of an object. When the tennis ball is falling on the wire, gravity is pulling the tennis ball downward, giving it more speed. Now, when the tennis ball hit the cardboard wall, because of Newton's third law, the tennis ball turned and hit the dominoes. Section D. Define work relating it to force and displacement. Work is defined as product of a force and distance over which the force is applied. My tennis ball is producing work because the force of gravity pulls it downward, and since the tennis ball is moving, this means that it is producing work. Thank you guys so much for watching the video. I hope you guys enjoyed. I basically use whenever my golf ball, oh my gosh, not my golf ball, my tennis ball. Okay, let's try that again. Some examples are a coin spinning, a coiled spring, a coiled spring. Okay, let's do that again. Distinguish, oh no, ringing the wrong one. Okay. Jeez. Calculate the potential energy. So for this, I use the kinematic, it's not even a kinematic equation. It's not even a kinematic equation. Okay. A position versus time. Okay. My tennis ball is producing.
What the deal? Bet. I got.
Are you sure about that?